Hi, my name is Kiran Baburaj. Today we are diving into a crucial topic: different types of insertion operations in linked list. In this video, we will cover inserting at the head, tail, inserting after a specific node, before a specific node, and inserting at a specific position with visualizations, animations, and step-by-step procedure for better understanding. Alright, we will explore how to insert a node at the head of the linked list. We will start with the visual representation of the process, followed by the actual code implementation. So let's dive in. We will start with the empty linked list, where the head pointer is set to none. Then we will insert nodes one by one at the head of the list. Here is our empty list. The head pointer is currently pointing to none. In the first step, we insert the value 10. Since the list was empty, this node becomes the head of the list. Next, we insert the value 20. The new node is added at the head and its point to the previous head node, which is 10. Finally, we insert 30. The new node becomes the head pointing to 20, which in turn points to 10. This is how the linked list grows at the head. Each insertion at the head takes at constant time, making it an efficient operation. Now let's look at the code implementation in Python. We will write a method called InsertHead that adds a node at the head of the linked list. First, we create a new node with the given data. Then we set the next pointer of the new node to the current head of the list. Finally, we update the head pointer to point to the new node. And that's it. The method returns the newly inserted node. Here are the key takeaways. First one, inserting at the head of the linked list has a time complexity of order of 1. The process involves 3 steps: creating a new node, linking it with the current head, and updating the head pointer. This method works for both empty and non-empty list. Next, we will explore how to insert node at the end of the linked list. In the first step, we will insert 10. Since the list was empty, this node becomes both the head and tail of the list. Next, we insert value 20. The new node is added at the end, and the tail pointer is updated to point to this new node. The first node now points to the second node. And finally, we insert 30. The new node becomes the tail, and the second node points to it. That's it, how the linked list grows at the end. Each insertion at the end requires traversing the list, making it an order of n operation. So let's look at the code implementation. We will write a method called InsertEnd that adds a node at the end of the linked list. First, we create a new node with the given data. Then we check if the list is empty. If it is, the new node becomes the both head and tail of the list. If the list is not empty, we traverse to the last node and link it to the new node. Finally, we update the tail pointer to the new node. Here are the key takeaways. Inserting at the end of the linked list has a time complexity of order of n because we have to traverse the entire list. The process involves 3 main steps: creating a new node, traversing to the last node, and linking the last node to the new node. Now let's explore how to insert a node at the specific position in the linked list. We have a linked list with 3 nodes. Our goal is to insert the new node with the value 25 at the position 2, which means the new nodes should be between 20 and 30. First step, we create the new node with the value 25. This node is currently disconnected from the list. So in order to insert it in the correct position, we traverse the list to find the correct position. Then we start at the head and move to 20, which is position 1. This is the node just before our target position. Now we update the pointers. The new node 25 will point to node 30 and node 20 will point to the new node. This effectively inserts 25 between 20 and 30. Let's explore how to insert the node at a specific position. First, we define insert at position method taking data and position as the parameters. We start by creating new node with the given data. Next, we handle the edge cases. If the position is invalid, we raise the error. If inserting at the start, we update the head and return the new node. Otherwise, we traverse the list until the desired position. Finally, we insert the new node at the correct position. And that's how you insert the node at a specific position. Let's recap the key points. The time complexity of the operation is order of n. There are 4 main steps: validating the position, handling the special case of inserting at the head, traversing to the correct position, and updating the pointers. Now we will explore how to insert a new node before a target node in the singly linked list. Now we have a linked list with 4 nodes. Our goal is to insert a new node with the value 25 before the target node 30. The first step is to create a new node with the value 25. This node will eventually be inserted to the list. Next, we need to find the node that comes before the target node. We start from the head and traverse the list until we reach the node with the value 20, which is the node before our target. Now we update the pointers. The new node 25 is placed between 20 and 30. The next pointer of 20 is updated to the point 25, and the next pointer of the 25 is set to point to 30. This completes the insertion. Now let's take a look at the code implementation for this operation. The method insert before takes 2 parameters, the target data and the new data. It checks if the list is empty and handles the case when the target is the head, and traverses the list to find the appropriate position for the new node. Here are some key points to remember. The time complexity of the operation is order of n, and always handle the edge cases such as an empty list or when the target is head, and make sure to update the pointers correctly to maintain the integrity of the list. Finally, how to insert a new node after a given node in a linked list. Here we have linked list with 4 nodes, 10, 20, 30 and 40. We will be inserting a new node with the value 25 after the node containing 20. First, we create the new node containing the value 25. Next, we save the pointer to the node that follows our target node, which is 30. Now we update the pointers. The node with value 20 will now point to our new node, and our new node will point to 30. Thus, we have successfully inserted 25 after 20. Now let's take a look at the implementation of the insertion in Python. Here we have our insert after method. We start by checking if the list is empty. If it is, we raise an error. Then we traverse the list to find the target node. Once we found, we insert the new node and update the necessary pointers. To summarize, the time complexity of this operation is order of n. We handle the case of an empty list, and we find the target node and update the connections accordingly. Okay, thanks for watching. If you found this video helpful, please like, share and subscribe for more content on data structures and algorithm. Thank you.